Hi, this is my EUC Bigot T4, and in this video I'll try to make a stand for this EUC. So the stand will support the aluminum block here from this side, go around the other side here. And this EUC weighs about 33 kilograms. I'm planning to upgrade a lot of parts here. This is the part that I 3D print with a nylon SLS. And I plan to make a new mudguard that mount from the inside of the EUC, and I plan to change this pedal from this aluminum. It's beat up quite a lot because I learned on this wheel, and I will reverse this pedal and 3D print with the engineering plastic. But first of all, I need to make it stand upright without turning it on. So I need to make a stand for this. Okay, I have already applied all the markers. So I should be able to scan from one side to the other and get the dimension of the tire in relative to the aluminum blocks. Okay, so I'll start the scanning, and I'll use the Gravity Summon S1 connecting to the Wi-Fi handle. I'll start by scanning the marker first using the global marker. Okay, I'm using my gaming laptop. Get about 40 frames per second. Because the S1 has a very large FOV, so it can track from one side to the other. Very easy, much easier than the Laptors. Okay, now I'm done with the global marker. Next, I'm going to scan with the point cloud cross line, 0.3 millimeters. Start scanning. Yes, I need a dimension of a tire. Okay, all done. Okay, here's the result. 2.6 million points. That's quite a lot. I think I overused the resolution. The details on the knob is also shows, which is unnecessary. I only need a dimension on the aluminum support in relative to the tire. Okay, let me export this as a point cloud ASC format. Okay, next I'm going to move to cloud compare. Okay, here's in the cloud compare. Okay, let me align this to the XY plane. I click on here, pick 3 points, 1, 2, and 3. Now it's aligned to the XY plane. Let me rotate it along the Z-axis using my mouse to align it. Okay, click on check mark and let me turn it upside down. I'm going to rotate the Y-axis 180 degrees. Change the color, and I'm going to move this to the origin point. Click on Save RS Format. Okay, here is in the Hotx Inventor. This is a point cloud from the 3D scanning. If you wonder if your wheel is not true, you've been through an accident and it might bend the rotating axis of the wheel and the motor, you can use the sketch to check it by dragging a horizontal line like this. Draw a perpendicular line on the rim, and you can check if the line is making a 90-degree angles. In my case, the wheel is quite through. There's no bending because I never been on an accident with this wheel before. Okay, let's move to the first part that I'm going to draw. I'm going to draw a support here under this aluminum block. So I create a sketch under the shock column. It's a column of the shock absorber. And I create this sketch about 70 millimeters wide and just a little bit taller than the tire. And next I extrude it for 12 millimeter in a thickness. And this will be the column of the stand. Next I create this sketch. That should be a stiffener for the column. I extended 35 millimeter. I want to control the movement on the sideway. Okay, and then I extrude it like this. And next I going to create a joint, a dovetail joint for the columns and the base. The dovetail joint I use will be about 10 mm wide and 7 mm tall at 60-degree dovetail. I put it here 3 of the dovetail, but 2 is enough just on the left and on the right. And I will join this column to the base mechanically, not using adhesive. So I will use a smaller clearance, 0.1 mm. Okay, next I extrude the dovetail. I add some height here for 5 mm and then I extrude it. I want this structure element to be high efficiency, so I make it hollow. I create a 3D sketch here for creating a pocket, and then I extrude cut it. So when I extrude cut the pocket, I will have more walls. Wall is stronger when you make a 3D printing, so I want to invest in the wall rather than invest in the infill. Infill doesn't do much contribution to the strength. And then I make some fillet because I want to print in this orientation, and if I put the fillet, the nozzle will run smoother than the sharp corner, so it will print faster. And I add more fillet here at the top. And next I'm going to create a cutout, pocket cutout, so that I have more walls. And I extrude cut it and put some fillet here on the corners. Also fillet here for faster printing, and it also looks better and stronger as well. Add some chamfer here on the edges. Okay, so I'm done for the first part. Okay, next, before I process to the next part, I run a simulation using ABS as the printing materials and apply 40 kilograms of load on one of the column. And the stress is only 12 megapascal, which is very small comparing with the 40 megapascal limit from the PETG ABS. If I don't cut the pocket here, there won't be any walls here. So if there is no wall here, there will be only infill. So the infill will carry the load, and the infill is not strong. So if I can turn the infill into the walls, the part will be much stronger and lighter. Okay, next I create a new part, the base of the stand. The size is 220 by 70. If you look from the top, and I extrude it 15 millimeter thickness. Okay, next I make a cutout for the dovetail. I project the lines from the columns, and I put a clearance here 0.1 millimeter, so it will be a very tight fit if it is print on the FDM printer. And I will extrude only 2 of the dovetail. Then I extrude cut the dovetail into the base. Okay, next I create a fillet here on 4 corners. So the base of the stand will be joined together by using this beam. So I project the sketch from the beam, which is I have already created. I put the cross beam here. The lowest point of the tile will be here, but this part I have a higher clearance for placing the beam. Okay, instead of printing the base with the infill, I will create more walls by cutting the pocket. I make a sketch here, and then I extrude it, add some fillet for faster printing. Okay, I cut another pocket here, so I have more walls. This will be extra wall that created by the pocket. So wall is stronger than printing with just a solid block and infill inside. So add fillet here and chamfer along the edges. And I put load into the simulation, 40 kilograms, just to see the deflection when I place it on an even surface. I place support here on the extreme edge and apply force to see how the wall is fighting against the deflection. Okay, next I mirror the parts to the opposite side and create a cross beam to hold these 2 bases together. Okay, now the stand is complete and should be ready for printing. Okay, here's in the slicer, split 3 layers of the wall. So it takes 3 hours to print and 154 grams of filament. So in total, I'm gonna need to use about 300 grams of the filament, but this stand has to carry the load of 35,000 grams. So it's supposed to be able to carry the weight that is 100 times of its own weight. The filament that I'm going to use today is from BQ Carbon Core 25 ABS filament. Okay, so I have some issue when I try to load this into a printer. You can see here the filament stuck to the roll. Some issue with the winding, and when I pull it, it's tear down like this. Okay, I think I know what is wrong with this BQ ABS filament. Last time I used it, after use I put it into a dryer for 4 hours, 80 degrees Celsius, which is normal drying temperature for ABS. But I think this ABS filament has a lower melting temperature than a regular ABS. So when I dry it, all of the filaments are well together during the drying process. So it's like I can't even move it. See here, it's all well together, and it's also well to the spool. So I cannot unroll this. It's all stick together. See here, it's all well up. I don't think this is usable anymore. Okay, so I'm going to switch to Hyper PETG instead. Okay, so I have already print 1/2, and this 3 pieces takes about 3 hours. And the dovetail is tight fit 0.1 millimeter K-length, so I need to knock it in because I don't want to use adhesive. I think it's stiff enough. Here's dovetail joint with a 0.1 millimeter K-length, and if you want to use adhesive, you may need to use 0.2 millimeter for the K-length, but I want to because this PETG it doesn't work very well with the adhesive. The EUC weight is 35 kilograms, I scale it, and the 3D print weight is 350 grams. So this weight 100 times more than the print. Okay, so look at the K-length through the dryer. Okay, thanks guys for watching. I'll see you in the next video.